I'm Omar Salam, PhD student in Ocean Engineering Department in Texas A&M University. So today I'm presenting inference of water wave surface elevation from horizontal velocity components using physics-informed neural networks. So basically, just a very brief introduction about the work. So why we are measuring the sea state. So basically sea state means like the significant wave height, significant wave period, and the directional spectrum of the wave of the energy or the energy waves. We are interested in this because this helps to better design the marine vessel and design the offshore structure, do prediction for the wave energy generation, and also do the coastal protection. So basically, we need to know more information about the energy in the wave, and the oceanic wave. There are two types or techniques to measure the sea state. The first one, which is the in-situation techniques, such as the wave pools, like just some resistive or capacitive wave pools, pressure transducers or wave buoys, and all of these techniques, like in-situation techniques, they are localized at localized points, and they are not giving so much information, but they are not expensive. The other techniques, like the remote sensing techniques, and these techniques, they give more information, like spatiotemporal information for a continuous space. However, these techniques are more expensive, and these techniques like radar or stereo vision system. I wanted to focus more on, like, in this slide, it says that the more you go from in-situation technique to remote sensing technique, the more information you can get, but the more expensive it will be. I wanted to focus on the stereo vision system. So basically, stereo vision system, it's a two-camera system, something like our eye. If you put something in front of your eye and like close an eye and open another eye and keep doing this shifting, you will find the object is shifting from left and right. And basically, this is how the stereo vision system is working. So when you have a two-camera system and you keep capturing from left and right cameras, you will find the objects are moving from left to right. And this horizontal shift from the pixels of the camera is called the disparity. And using this disparity and substituting in some equations, I don't want to spend the time to describe these equations, we can do something called the depth map. So you can know that this tree is much near to the camera than the building behind it. So basically, this is the stereo vision system. So it's a tool to measure the depth or the distance from the object to the camera. We have used the stereo vision system to measure the wave height. And basically, this experiment is happening in-lab experiment in Ocean Engineering Department in Texas A&M University in College Station. So basically, we used a stereo vision system to measure the wave height, and this is the wave profile measured by the camera, which is attached here or installed here. Also, we did the same for an offshore, like for an outdoor experiment. So this is a home-built, like, or an in-lab built stereo vision system to measure the water surface profile in Galveston in Texas, United States. And we were also able to reconstruct the surface profile. The question is, like, as we've seen before, that the stereo vision system is based on two-camera system. So the question is, can we use only a single camera to estimate the wave height? The answer is yes, and the answer is yes using the Fourier feature physics-informed neural network. And basically, this is the big picture of this paper. FFPEN, Fourier feature physics-informed neural network, and the big picture is, if we have a pre-calibrated camera and we can get the velocity, the horizontal velocity components of the water stream or the wave stream, then we can feed this free surface planar velocity to the FFPEN model. Then we can have prediction for the surface elevation and also the vertical velocity component. The first question is, what is PEN, or what is physics-informed neural network? Physics-informed neural network, it's a deep learning tool which works as a method to solve forward and inverse partial differential equations using some initial conditions, maybe and boundary conditions. These initial condition and boundary conditions may not be well defined, and maybe also you have only some sparse defined data or solution in the domain. So the physics-informed neural network, you have a neural network, but also this neural network is not only trained to memorize data, but also it's trained on how to solve a partial differential equation with some information either embedded in the spatiotemporal domain or information for the solution itself. Another thing I wanted to mention before jumping to the implementation, which is a Fourier feature. A Fourier feature is a technique that helps the neural network to learn high frequency or multiple frequency data much faster. So if you look at this graph, you'll find like we have a signal composed of two frequency signal. Like we have a high frequency, which is 10 Hertz, and another low frequency, which is only 1 Hertz. And they are like added to each other. And this is the wavelet transform for the neural network to learn this data. So you'll see like after around 4 cycles of iteration, the neural network started to learn, it already was able to learn the low frequency solution from the beginning of the training. However, after 5 training cycles, it starts to learn that, hey, there is a higher frequency solution in the domain. However, when we use the Fourier feature, and the Fourier feature is adding a carrier signal of sinusoidal representation, which help to accelerate the prediction of high frequency solution. So the Fourier feature neural network was able to learn the 2 frequency bands or the 2 frequency solution from the beginning of the training cycle. And then this is the architecture for the physics-informed neural network for the free surface flow. So basically, we have the input to the neural network, which is the XY, which is the 2D spatial domain, and also the time, which is the temporal domain. And then we have the hidden layers and the output layers. And then we have here the physics-informed part. The physics-informed part represents the physical equation we are interested to solve, like the continuity equation, the momentum equation, and also the free surface equation. And then here we do the back propagation step to do optimization for the network parameters. So this is the physics-informed neural network model for the free surface flow. When we add the Fourier feature part to accelerate the solution for the multiple frequency problems. So we just add here the spatiotemporal Fourier feature decomposition. So we add all of the equation we have to a higher frequency carrier signals. And then here we also add the spatiotemporal Fourier feature composition, which is just a linear transposition for all the solution of the signal. Model verification. So basically, we didn't implement this model verification to experimentally, but basically we did it like numerically. So we obtained a free surface planar velocity for the horizontal velocity components, and then we fed these horizontal velocity components to the Fourier feature physics-informed neural network model. Then we estimated the water wave surface elevation and the vertical velocity component. How did we do this? We generated wave numerically using OpenFOAM, and OpenFOAM is a computational flow dynamics solver based on finite volume method. So we simulated a 2-phase problem using interFOAM solver for a cryzo container ship moving in a still water, which is generating Kelvin wave pattern downstream of this moving ship, and you see here like there are waves generating downstream. The problem, we did the problem for fruit number of 0.26, and here are the rest of the parameters. And then this pink square, this represents the area that we collected the data and we tested our our model. This image, this represents the mesh of the problem or the grid. You will find that you can see that the grid is very fine near to the free surface region, and its coarse far from the free surface region. We simulated the problem, half of the problem, due to the problem symmetry. And here is the results for the OpenFOAM simulation. So just the OpenFOAM simulation is responsible for giving the correct data for reference data to test the model. The U1, this is the velocity, the stream velocity downstream. U2, this is the lateral velocity. U3, this is the vertical velocity, and eta, this is the surface elevation of the generated Kelvin wave pattern downstream of the moving vessel. When you see, this figure represents the prediction of the model. So here is the reference solution by the OpenFOAM. And this is the reference solution for U1 using physics-informed neural network with no Fourier feature. And this is the U1 for using the physics-informed neural network using the Fourier feature. So when you look at the difference between three of them, you will find that the physics-informed neural network with no Fourier feature was only able to predict like the laminar solution, or was only able to predict the low frequency solution. However, for the Fourier feature addition for the network, it was able to predict both the laminar solution and the turbulent one, or the low frequency solution and the high frequency one. This is the same for the U2, U3, and also for the surface elevation. And also I wanted to note that the network is only trained on the U1, U2, and however, for the U3 and the eta, this is the network prediction. So the network has not seen the vertical velocity component or the surface elevation in the training data. It only sees the U1 and U2 in the training data. And it was accurate, properly predicted the surface elevation and also the vertical velocity component. Also, other results, let's see here that for the physics-informed neural network and like comparison between the model behavior for the physics-informed neural network and the Fourier feature physics-informed neural network, that the training loss for U1 and U2, it was better for the Fourier feature part. Also, the mean relative absolute error for prediction of the surface elevation, it was also better for the Fourier feature part. And for the U3, which is the vertical velocity component, you can see that the Fourier feature part is converging much faster towards the correct solution. And here for the PDE residual, like the continuity equation and the momentum equation residuals, you can see that the physics-informed neural network has lower error compared to the Fourier feature part. And this has like a clue that the physics-informed neural network converged towards a correct solution, but this correct solution does not represent the problem, what the problem really looks like. Like converging to a solution that satisfies the equation does not mean that this convergent solution is correct. It only satisfies the equation, because basically it satisfies the laminar equation of the problem, not the turbulent one. Future work. The future work is to test the model on an experimental validation. We started some steps towards this. So basically, we attached a stereo vision camera to a drone, and then we already fly the drone to up to the Somerville Lake in Texas. Somerville Lake, it's the northwest of Houston City in Texas, and then we collected data for the free surface elevation. And also we use like these yellow things. This is like wave buoys to do validation between the stereo vision camera and the and these commercial wave buoys. And then we collected the data from the depth camera. We collected the left and right images. Then we use the stereo vision algorithm to do like 3D point cloud. And then we can extract the water surface elevation for the four different timestamps. And then we did a comparison between the SOFAR buoy and the stereo vision camera. But the next step is to implement the model to these experimental data. Just I wanted for acknowledgement, the part of the stereo vision data is funded by the ONR, which is the Office of Naval Research in the United States. Yeah, thank you so much for your attention, and feel free to ask any question.
Very great and intense work carried. Very good work, Aslam. Really is good work. I appreciate
Thank
the
you.
work which has been done and the effort which has been carried. So, like when it comes to neural network model over here for oceanography, the work which you have carried with respect to the simulation, like how was it? What difficulties usually you faced because the waves and other things you see the real-time data and unnatural data which you get for the survival of those structures, which you mentioned in the initial stages, right? So that is what intention is. What I believe, what you have done with your building a neural network. Am I correct? Like you want to understand the water wave surface elevation for that so that it helps to understand to design those structures or something, and for a safe structures. Right.
Like basically when we design like an offshore structure, we want to know the energy spectrum in this region. So basically one way is to carry a stereo vision system in a drone and then fly this drone over the place that the offshore structure will be installed that time. But the problem is, for a really good reading for the stereo vision system, you need two camera system, which is really very long, like 3 meters in wide, to scan really large data. However, when you ask for like stereo vision system with 3 or 4 meter wide baseline between the two cameras, you need a really large and really powerful drone. And these powerful drone, at least they are around $10,000 or $20,000 that will be able to do the test for around 2 hours and be able to carry these two heavy cameras with their trigger system and their data acquisition system. So it's very expensive. So the idea of our model, hey, we don't want to use two camera system to do stereo vision, because we already have the equation for the ocean waves, and we can use only so our model is to use a neural network to use only single camera instead of two camera system, which we can do the same thing without a very expensive drone, but we can just get a drone with the size of our hand and install only a single camera to give us the same results.
So the ocean photos were taken and and image processing techniques are used for the same.
So sorry, I didn't get the question.
I asked like to understand the waves. You usually use the drones to capture the images of the wave motion of the ocean, and then is it like you use the image processing technique initially?
Like
the model?
it's I cannot say it's only images, but I can say it's a stereo vision algorithm. So if you look at this slide, so basically the two camera of the stereo vision camera, so you get the left image and right image, okay? And from the left image and right image, you can estimate the disparity. So now let's do a very quick experiment now. If you put your finger in front of your eyes and then close one eye and then close it and like keep switching between these two eyes like this, okay? You will see your finger is going left and right, right? It's going left and right when you keep this, doing this. Okay. So this shift left and right, this is called a disparity. And this disparity, when we substitute in very basic equations called like you can just Google it, like the stereo vision equations, you can convert this disparity in terms of pixels into in terms of meters or distance from the camera to the object. So now we have the disparity for every pixel in the two images. So also you have the distance from every water particle. It's the distance from every water particle to the camera for the whole pixel map. So also you can get the water surface profile for the area you already scanned using your camera. Then after applying the stereo vision system or this disparity thing or this shifting thing, you can generate the point cloud, which is the XYZ for coordinate for every point in the water. And then we do some coordinate transformation, and then we can extract the grid, like the grid for the water surface profile. Then we can repeat the same for every time we are interested in.
We have I have we have a new topic. It's in management of human resource management, and linked about the governance and environmental performance in the company. So the general topic is about human resource management and CSR, the company social responsibility. So I'm from IPAG Business School. I'm from Paris, and I am associate professor from Paris in the Department of Finance. Our plan today is the first is our new after our motivation. The third, the literature review. It is the development and the result, and we finish without the conclusion. So our review in the recent years, there has been a shift from a financial focus on the performance of organization to more integral indicator, including social, government, and government dimension. That's we can see the research of Gomez and al. 2004 or Young and Bonsad Job 2017. So their CSR activity not only create reputation capital, but also increase public trust, leading to a positive market reading award, improved financial performance. That's for the company. Also, we can see that the government has a structuring role in the plural regulation of the organization in the field of CSR, the company social responsibility. Our motivation to this paper is the first environment performance and production and process efficiency, stakeholder relation, regulation, complicate and financial impact, environmental impact, and the corporate image. There are the research of Andre and Gisson 2006. Also, we can say that the firm that engage in environment and social activity create a positive and significant increase in performance and higher stock return. We can see the research of Von Axe and Zeiger 2014. Also, seeing the Nielsen and Howes 28 and the Gould and all research in 2011 report gender diversity in the company can have effectiveness and contribute to development of activity. This is that contribute to the effectiveness and the smooth function tuning. So our literature review is or the theoretical text we have is three. Theory, the human capital theory, stakeholder theory, and the agency theory. That's the first is the stakeholder theory, and we see the research of Eel and Jones 1922, were proposed to broaden the contractual vision of the firm, which can be personal as a node of contract between the manager and the stakeholder. But the foundation of agency theory, we can see the research of Beryl and Mean, the 1952. That's it based on the separation of ownership and control in the modern form. the third theory, that the agency theory, when you see the research of Jensen and Mackling in 1976, who offer a stimulating conceptual framework for understanding the economic interest that the company may have in communicating its environmental commitment to stakeholders. So our model research, we can see the role of gender diversity, board gender diversity. So we have three variable, that's the governance, the social performance, and financial performance. What their impact on the environmental performance? That's the model number one. Number three, we can add the board gender diversity. So when we have a board gender diversity in new variable, what is the impact of the three variable on the environment performance? After one please. So that's our topic, the impact of government and on environmental performance, the role, the mediating role of the board gender diversity. And we can add it to other variable, the social performance and financial performance. In this study, we selected the score of variables, exemplatory and explanatory variable, to identify the link between the three variable and the environment performance. Our resource data is the Thomson-Reiter data stream based that provide many score from 0 to 20 from 0 to 100, with 100 is the beginning very good and 0 is very, very poor. So example for the governments, we can for our company, the score is between 25 and 97 from the good to the better company. Our research methodology from our resource database, the Thomson-Reiter sets for each access, and that's resource assess a number of company of which ESG data is maintained and the ESG score that are calculated, considering from 6,000 company in the world in this database. This indicator are used by many research, same the Kim and al, Su and al, Young and Bastomsi, and Jahman and Gayes and 2020. So our number of company, we have 29 company, power generation company around the world are representative. This company are a representative of CSR, of the company's social responsibility activity that have a role to play in the company under different type of management, strategy management, risk management, and change management. We can see the research of Arjales and Mandi 2013 and the research of Jaman and Grace 2020. Our study now mobilize data collected between 2002 and 2021 from a sample of 29 international power generation company. This international power company is based in Europe and USA and in the Asia, in Japan or in China, 29 international power company. So despite this, our sample remain representative. To estimate our dynamic model, we used data analysis using the panel data fixed effect regression method. This method is used by Jahman and Gaines 2020, and the regression with their control variable. We have three control variables: the age of company, net risk, and the return on equity. our result. Before the result of our model, we tested we must use the Shapiro-Wilk test for normal data. This Shapiro-Wilk test is a test of whether a data still followed a normal distribution. Therefore, if the p-value of the test is significant, the sample does not follow of normal distribution. Following this test, only two variables that do not follow a normal distribution. That's the two variables is employee health and safety teams and woman manager work. So we have two variables, human health and safety teams, variable number one. Woman manager workforce is the variable number two. There is no normality, so we can see the presence of some phenomena that can influence all the variable used to this. Our descriptive statistic, we can see the number of variable that is the environment score between this score, this rating in the data stream, or also the governance, the research, the return on assist, net risk, net firm risk, social pillar score, that's the rating of an impact of company in the social action, the age of company, environmental social pillar score, that's also the rating of company in their environment action, the workforce accident, and we can see CS strategy, board size, board gender diversity, accident, human right. That's are the variable, the social and the financial variable to test our model. We have two models. In this research to justify the choice of our fixed effect regression model in panel data, it's essential to perform the Osman specification test to choose the model because we have the fixed effect and the random effect. We must we must see the result of human specification test to justify our regression model. It will be a fixed effect or random effect. So the result of human of Osman test specification, we can see the result. So after this result, we can do that. We must be choose the fixed effect, not random. So after seeing the Osman specification result that the Q2 Q2 is 20.07 and probability of Q2 equal 0.11 or R.118. Thus we can choose the fixed effect regression. So we can see now our first model. The first model is the environment pillar scar is calculated about a constant and some expected variable. And the second, we added the board gender diversity percent for seeing what's this impact of this variable in our model. So now we can see the result of regression. We have now the model 1 and model 2, and we can see the better result. What is the better? We can see the research, the return on assist that's negative and equal negative 0.23. And when we added the board gender diversity percentage, the ROE will have a negative impact, but it's increase. It's not decrease, it's decrease to 15. But we can see also the constant, it is negative 24, and when we added the board gender diversity, the constant will be 22.89. But we can see also the impact on the environmental innovation score, that the presence of board gender diversity or the mixity in the board of a company ameliorate the impact in the environment innovation score and in the government pillar score. We can see that the government pillar score it's negative 28, and now it's negative 70. So we can conclude, or we can say in the that the presence of gender diversity or gender board diversity is really seen as an advantage for board, and thus has multiple contribution, the different point of view, behavior, knowledge, experience. It has a positive impact on the different working group, and the teacher review underlines that gender diversity of board of director is of real interest of the company, as it's positively impact its performance, both social, environmental, and economic, where the work of employee is more effective in the team is mixed. Thus, we can say the work of Ilman and Dals Zay 2003. We can say also the board gender diversity is of a real interest of the company, since it has a positive impact on the performance, both social, environmental, and economic, where the work of an employee is more effective in the teams it's mixed, which confirm the work of Ilman and Dalzai 2003. Thank you.
These research studies have an issue and then also try to solve the problem. The issue is about as the student population become diverse in schools, especially the minority students have difficulties in learning STEM areas. So schools are facing significant challenges in effectively developing STEM instructions to teach the minority students and close their achievement in STEM areas. So that's why this study started. As a solution, many previous research studies emphasize the culturally responsive instructions, because when minority students located in their daily lives, integrating with their culture, then they feel very comfortable, respected. So that's why in instruction, teachers need to include the students' culture. So that's the solution. And next. Can we go next? So this study tried to educate the future STEM teachers, learn how to develop culturally responsive instruction. The culturally responsive instruction enabled the teachers to resolve potential cultural differences among students in the classroom, and also create an equal learning environment for all students, including the minority students. So that's why this study tried to teach how to develop the culturally responsive instruction to the future STEM teachers, and then see if their STEM affinity improved. So go to next. The STEM affinity means the individual self-efficacy and mindset, and also their identity. So these three theories combined. So in our research studies to measure the effect of cultural responsive instruction on future STEM teachers. We use the science affinity, how much the future STEM teachers improve their science affinities. Next. So again, this study is to measure the cultural responsive instruction training is effective on future teachers. So the research question first is, does the smile in transportation. Again, the cultural responsive instruction training is called summer multicultural interdisciplinary learning in engineering, learning for engineering in transportation. So I made it like shortly smile in transportation. So this project can help future teachers to increase their knowledge in transportation. And second research question is, does the STEM in smile in transportation improve their affinity in transportation? And third research question is, does the smile in transportation promote their cultural competencies? And next. So for this research studies, we have actually, I had like a training participants, like 30 participants, but only 9 of them answered the survey questions. So the result are shown with the 9 future science and math teachers. They are normally third junior and seniors, and then male and female students, and then their affinity you can find from here. And then also their okay. So with the 9 participants, their knowledge of transportation, as you can see from the mean value, pre-test show 6, but then post-test show 9.3. So that means their knowledge improved. And next. And then their scientific affinity, especially their teaching efficacy. That means how much they are confident in teaching STEM areas. So among the 9 participants, pre-test to show 3.87, but then post-test to show 4.09. So it's increased next to. And then their cultural competencies, after they integrate cultures in their teaching, their cultural competencies, as you can see from the mean value, is increased a little bit. The slight increasement you can see, but because the duration of this training is just 3 weeks, so that's why even if it's increased, but then the amount of the cultural competence a little bit less than I expected. Okay, next. And also at the end, I had some interview with the participants, and then the participants said that this Smile in Transportation project was helpful for them to improve cultural competence by developing the skills of cultural responsive instructions. And also they expressed some kind of concern about the lack of diversity and inclusivity in STEM education, particularly in relation to gender, ethnicity, and students with special needs. The participants also highlighted, would you go, yeah, highlights the importance of incorporating different culture, diverse role models, and realistic example to make STEM subject more reliable, relatable, and inclusive. So the students, the future STEM teachers, they start to think about the diversity in classroom and how they're gonna handle, how they're gonna make that diversity for all students learning. So they start cultural competencies. And also they said the needs to create a supportive and welcoming environment for all students, addressing biases and promoting growth mindsets. So after this training, cultural responsive instruction training, the future STEM teachers start to think about diversity and equity in their classrooms. But so yeah, that's about it. Thank you so much.
I'm currently in earlier stage of my doctoral journey in the collaboration PhD program between two universities, actually in Morocco. Yeah, it's Faculty of Science and Technique of Mohammedia and INSIAS, which is a university of Mohammed V in Rabat. So today I want to share with you my first paper titled From Monolithic to Microservices, a Decomposition Technique, where I try to actually to discuss about the migration technique that proposed in the literature, and I will actually share with you our approach based on process mining. Okay, so let's get started. So we'll take just an introduction, background review, where we talk about the keyword and the related work problem, and we will present our approach actually, and we will finish with a conclusion and perspective. Okay, so in the introduction, I have to say that with all these techniques that we have, the enterprise starts usually by using a monolithic application. For sure, monolithic application is just a simple application. We have just a single code base, a single database, where we have all this code. And whenever they want to add some functionality, they have to change in this code. And that's the problem, because as this application grew up, the code became difficult to maintain and difficult to scale up actually. And that's why we talk a lot of in this earlier year about microservices. So microservices is just a single a architecture for sure, where we have every or each microservices is depend or can work independently to another microservices. Okay, so just to another word, so the organization starts with a monolithic application because it's simple to develop and to deploy. But as the application grew up, they want to migrate with the microservices, and we will see why exactly. And we'll talk about the advantages of using microservices. Okay, so before talking about our approach exactly, we will talk about just give a definition to all the keywords that we'll use. So to do this decomposition to this multi-application to microservices, we need actually to define what is multi actually and what is microservices, and we will define process mining as well. So let's get started with multi-application. So we can define multi-application as a software architecture in which all functionality is contained within a single program. And this is the problem, because this architecture making it impossible to separate the components, because we have a strong relationship between all our code and all the components. And whenever we want to change a single functionality, we need to update the huge system. So this architecture has some advantages but has a lot of disadvantages. So this architecture, for sure, it's simple, easy to deploy, and easy to test also, and error tracing. But the problem here is, for example, if we would like to scale this application, it's very difficult, and especially when we have a very huge code in our application. So we have scalability is limited, and we have a relatability issue, for sure, because we have a strong relation between components. So whenever we try to modify some component, we may have a lot of errors in other components, and lack of flexibility, for sure, because we need to deploy our application in a single language of programmation, and we don't have this possibility to use a lot of languages in the same application. And deployment speed goes down, for sure, because all the application, it will be in a single code with a single database. Okay, so let's talk about microservices. So I will just read this definition by Ton Jonas. So he said that a microservice is just a small application that can be deployed independently, scaled independently, and tested independently, and that has a single responsibility. So what that means? So microservices is something that this is a service which is small. Small, that means each microservices has a single role, a single responsibility. So we can define a lot of microservices. Each microservices has single role. For example, we can have a microservice just for sign in or sign up in our application. That can be useful. For example, if we would like to modify this, you can just access in a specific microservices without touching another microservices, or to touch a huge system. So we can say that microservices are autonomous. What that means is just each microservices process a distinct set of capability that allows it to run without relying one to other microservices. Okay, so we have cohesive. That means that each microservices have a distinct, well-defined role. When a microservice is cohesive, it's simply we can simply comprehend and understand the code, and manage and grow, and add some other functionalities. Loosely coupling, this is the important advantage of microservices, because each microservices is independent one from another. Okay, so the third keyword that we will use is process mining. So process mining is a huge domain, but what I have to say here is we will use process mining to collect the data and to represent actually this data, because the data for us is just the request of the user. For example, we will add an ID for each user, and we will see all the requests of this user. For example, sign in, after that the homepage, and all these things. But we actually focus on the classes and methods will be launched by this user. Okay, so let's talk about related work. But before that, I will just I have to say that in the literature we have migration approach. So the first one is static analysis. What that means is the decomposition actually of monolithic application to microservices is done manually by developer or by architecture, etc. So they take just the source code and they try to break the dependencies statically and manually. But here's the problem is we don't actually do this decomposition based on the user experience. But here in the dynamic analysis, it's very different because what is important for us is the user runtime execution. So we take the user runtime execution to actually to detect this decomposition, dependencies and between classes and between objects, for sure. And model driven is actually a type of decomposition when we try, for example, to decompose this multi application, for example, just based on the functional or non-functional requirement or based on business capability of the organization. But all these things, static analysis and model driven, is done manually. Okay, so I have read a lot of articles, but I chose these 4 articles. So the two, 1 and 2, just try to use the model drive migration approach. So the first one tried to decompose actually the monolithic application based on process or business process or business capability. And this is the problem, is we need actually to understand the enterprise, for example, to actually to define all these business capability for this organization. And the second one, try to decompose based on the data flow diagram. All this decomposition is done manually, but we'll try to actually to generate a framework that help us to detect all these dependencies and break these dependencies to generate microservices. Okay, so the last 2 articles, they use dynamic analysis, and as we can see, we can combine 2 migration approach together. So the third one, they use actually the process mining, but here it doesn't talk about the decomposition of database also, because as we know, microservices is a code base, but also each microservices have to have a database. So just to define actually what we need is we need a decomposition that take the user request to actually define all the dependencies that we have in our monolithic application and to perform the microservices to get and to have the maintainability and performance. And also we need to decompose the database to affect to each microservice its database. And all these will be in runtime execution. Okay, so let's talk about our approach actually. So here we will take the monolithic application. Just say that it can be multi-application or it can be a microservice that we want actually to decompose. After in the source code, we will add a script just to have this capability to see all the requests of the user. So each user try to do this and this and this, and start by, for example, sign in and contact us, etc. So all these stars will collect them in the log file, and after we'll use the technique of process mining, which is process mining in configurable term. what that means is we will just focus on the variability. So for example, if all the users start by signing, and after we have a group of users that they launch, for example, home page, and another group launch contact page. So here we have a variability. So we'll take this to actually to see where we have the strong dependencies between classes and objects, and if we have the capability to break down these dependencies, we can actually generate microservices, a meta model of microservices. It's gonna be for this time it's just in the code, but after we will do the same thing for the database. But because here the database for us it will be a huge database. So when we try to decompose the code, we will try also to decompose the database as well. So at the conclusion of our work, I have just to say that it's actually my first experience, but it's I really enjoyed to share with you this, but and I will for sure continue to as I told you, the decomposition of database in the multi application have a strong it's a strong job, but also it can be useful if we can do this, and if we can generate actually the framework that decompose the code base and the database also of the Molotic application. So thank you so much for giving me this opportunity, and welcome to you.
Hi. Hello, everyone. So thank you for the time. So today I'm gonna present our research on air-sintered copper nickel resistor with aluminum layer for oxidation prevention. So for the introduction, here we know that the concept of the resistor has already introduced way before the development of thick film resistors. However, the development of thick film resistor has just begun in around 1950s, 1960s. And at that time, people just start the development and they search for suitable materials and how do they apply that materials for the thick film application. And for the 1960s to 1970s, the research developed to find the optimum formulation, and they introduced the printing technology. And in the 1990s, the thick film resistors already start to industrialize and got the widespread adoption. And now we just work on how to miniaturization and integration. Okay, so why do we use this technique? I mean, like our research. So we know that the alloy that's used for the thick film resistors, the most alloy is the ruthenium base. The sintering condition is in the ambient air, and also the silver palladium also in ambient air. But those materials are really expensive and not stable. And then for the copper nickel alloy is quite economic, but the sintering condition, it needs to be reduced atmosphere. So in our research, we do sintering in ambient air. So in here, so we can see here, if we have only metal alloy printed on the substrate and then sinter in the ambient air, the metal alloy will just directly oxidize because the nickel become nickel oxide and the copper become copper oxide. However, in our research, we put the blanket on top of the metal alloy, which is metal alloy here is copper nickel. The blanket is aluminum layer. So when we sinter this metal and its blanket under ambient air, the blanket will sacrifice itself to be oxidized. So because the oxidation only happened in the blanket, so we save our metal alloy. Right. So for the experiment, first we make the alloy first, the powder. We mix the powder, nickel powder and copper powder with a ratio 7:3. And for the thick film, we add the binder and organic solvent. And then we put it in the planetary milling and triple roller mix to mix it. And then we screen printing it, curing to dry, and then sintering at 600 and 900 to see what's the difference. And then for the cooling method, we use quenching, which is we take out our samples directly. And if you remember before, we have the blanket, right? The aluminum blanket, we etch that blanket. So we just use the nickel copper without the blanket. Okay. So here, we have three kind of samples. The first one is just the metal alloy printed on the substrate. And then the second one is metal alloy with just one layer of aluminum paste. And then the third one, we just have like thicker layer of the metal alloy. Okay. So discussion for the XRD result. For the single layer, there is a nickel copper oxide here in the face. It's only shown in the single layer in the 900 degrees Celsius because the copper like diffuse progressively to the aluminum layer and turned aluminum spinel into the aluminum spinel to the solid solution aluminum rich spinel. And then the copper oxide also seen here in the 700 to 900, but not in the 600 Celsius. So we conclude that during sintering above 600, the copper diffuse to the aluminum layer and reach the surface of the aluminum layer and get contact with the oxygen and oxidize. However, with the samples with the thicker layer, or we call it here the double layer, there's only the thicker layer like prevent the copper and nickel to go to the surface because it would be like thicker pathway. So the copper and nickel will have more prevention to get the oxidized. So here we got like little nickel oxide here, but there is nothing else. It's just a contamination during our experiment. Okay. So for the thermal analysis, we do the DSE and TGA. And in the DSE graph, they are not flat, which means the oxidation keep occurring during the process. And for the aluminum, in the thinner, without the aluminum layer, here we have the endothermic here. It means the copper nickel melting point. And for the samples with the layer, aluminum layer, there are two here the dissolution of the aluminum to aluminum particles. So for the TGA here, we can see that the samples with the thicker aluminum layer will have more mass gain, which means the oxidation happens more with the more aluminum layer. So for the morphology here, we can see the from the 600 degrees Celsius for the sintering. Here is a OM for the copper nickel with the aluminum layer here. So we can both see from either 600 or 900 degrees Celsius sintering, the oxygen layer only can be seen on the aluminum layer and not to penetrate further into copper and nickel. Here, the oxygen layer only on the surface of the aluminum layer. This because as part of its naturally reactive tendency, aluminum will oxidize rapidly and easily when exposed to the air, because we are sintering in the air, in the ambient air. And this alumina or aluminum oxide has ability to stop further oxidation. Because in this study we use alumina particles like quite big in the micron scale. There will be tiny surface area that allow oxygen to penetrate deeper, to reach deeper to the layer through the space between the alumina, but it will be it will be slowing down and eventually stop. That's why in the thinner layer we can see in the okay. So for the conclusion here, we successfully sinter the copper nickel alloy in the under ambient air at the 600 degrees Celsius and 900 degrees Celsius for the oxide-free copper nickel. And for the electrical properties for the copper nickel alloy resistors, we measure the resistance value is 463 10 to minus 9 ohm meters. Okay, thank you.
I'm Hossein Rashid from the Yüzencil University of Turkey, PhD candidate. My paper title is about the study of fatal crashes, accidents in Iraq, especially Kurdistan region. I will just try to let you know again. This study is about traffic fatal crashes, accidents, and we are forecasting the future of the next year of Iraq accidents. So I hope that all of you have my a slideshow and my voice and my picture. So we all know that the traffic accident is a main reason of the death in worldwide. One of the, we can say the third reason of the death in all around the world is the accidents, and it's increasing every day because we have increasing the number of the cars and increasing the number of the inhabitation, the people around the worldwide. So the deaths and accidents cause of these increasing of the inhabitation and cars will go forward day by day. So according to the WHO, every year about 1.2 million people is dying of these accidents. Let's say fatal crashes. This is another let's say, presentation. If I have a time, I will let you know what's the difference between the accident and fatal crashes. But let's say fatal crashes here. Every year we have 15 million people injured by these accidents. So this is a main, let's say, problem in all around the world, and we should just work on it. This is the importance of my study. And also, we know that these injuries and deaths will have a lot of side effects and negative effects on the society. So we should try to work on it and first of all know what's going on. The data and the place that I worked on is Iraq. Iraq, we know, is a country, let's say, in the Middle East. And especially we worked on the Kurdistan region with, let's say, 5 million inhabitations and 1 million cars there. Why we do that? Why I'm doing this research in this place? Because if you look at the budget of this country, it's 153 billions per year. And there is no insurance industry in this country. No private company and nothing as a governmental law to we have insurance there. So simple, if I tell you everyone have a car crash there, there is nothing, and they should just fix all the problems by themselves. There is no car insurance and there is nothing as a governmental law. So it's a good, let's say, opportunity for companies like worldwide companies to come there and try industrial of the insurance companies. So my research is, let's say, not this research. I have a lot. All of them is about this title, and we are trying to calculate the risk and car insurance, especially car motor insurance risk in the Kurdistan region. So what we are doing right now, we are forecasting, predicting the future in the next year, how many, let's say, car accidents, injured people we will have, and death people we will have. Okay, if we want to just so briefly analyze the or country Iraq data, let's say, and compare these deaths and car accidents with the another countries. I just made some rates, and you will see here the red one is the or country. I mean the Kurdistan region. It is so high risky. To the, if you want to rate it with other countries like United Kingdom, Sweden, France, and United States, we have two compares here. In the right-hand side, we will see car crashes per motor. How many motor we have? It's about, like, say, 1 million we have in Iraq, and it's per 100,000. So we will see a lot of risks in here. Depend on other countries. And another one, the left-hand side, is the data per inhabitations, the people that they are in the Kurdistan. As I told you, we have 5 million people there. It's nothing. And we have a lot of, let's say, we have a good budget there. So worldwide, if we want to look at this map is made by WHO. It shows us the risk of car accidents or injuries or whatever in deaths, let's say, in worldwide. You will see the Middle East countries and African countries, and somehow the let's say South American countries, they have a lot of accidents, and the rates there is really huge, especially in the African and Middle East. So we know that we are dealing with which kind of country, which kind of culture of driving. And also, this is the data of Iraq from 2000 until 2010. That one of the main reasons that Dr. Kumar also were asking all of the people that they were presenting. One of my major problem in my study was collecting data, because we know we are facing a Middle East country, let's say, or like Iraq. They don't have any plan, Ministry of Planning. They don't have any, let's say, collected data, any system that you can just find the data. So I will let you know how I try to collect this data for the first time in Iraq. Even their let's say, government, they don't have a data. They don't have an actual and accurate data, but I try to find some new ways to find it. So we know that it's going by an increasing trend, and we will try to see what we have. Our object is to find the next year data and forecasting. So we are using time series method, especially box jinx method. It's a method that most of the let's say last articles, they try to use it, and it's accurate. I just wanted to just give you a notice you will have in your mind. All of you are researchers, people. Try to know that the time series method is we should use it for the data that there is no other, let's say, causes that they will affect on them. How? I will let you know better. For example, I can use time series data on the weather forecasting. For example, next year, how much we will have the raining, or how many accidents we will have. Okay, but I cannot use the time series data for the oil or the price of the oil, because the price of the oil is not related to the backward data. It's related to the maybe sometimes politics, maybe sometimes the wars, I don't know, the Middle East situation. So we should know when we should use the time series and box jinx. So I have some, let's say, I made some symbols for my paper, a number of the accident, number of the people that injured, and number of the people that died in these accidents. Then this is my procedure for collecting data and have, let's say, a little bit accurate data in the Iraq country. If you have 3 sources of data, the 5 police reports, we have, when we have accident, the police goes there and they have some reports there, and they will use the some forms to give us the data from accident, people who died, people who have injured, and whatever the location and other stuff from the accident. We have the hospital certificates. Maybe we will have some traffic accidents that they didn't ask for the police to come, so they directly go to the hospitals. So some of them maybe in the villages or somewhere outside of the city. And third, it's a court vital statistics. Court vital statistics is the number of the people who died and the cause of them. You have all of the people who died in the country. This is, we can say, the actual, and you can just count on it, especially for the deaths. And they will give you a cause of death. So we just choose the people who died by the accident. From these 3 sources, we try to find actual accurate data. And as I told you, it's the first time that someone who's doing that in the Erbil and let's say in Iraq, and also government, they don't have these data. As I told you, I'm using the forecasting method. We have a lot of methods for forecasting, and I'm using quantitative time series. I don't want to take your time by explaining what's the time series is, what's the box jinx, but I will let you know by a special, let's say, maybe picture. You will understand what's the time series is and how can you use it. This is the box jinx method. We will have the data in the first step. You will see we have in the first step we will prepare the data, and then we will put it into the model. In this model, we will try to evaluate this model. For example, is it, first of all, is it stationary or not? Is it seasonal or not? The AIC and the PIC factors will work or not. I will try to explain what are these names that I'm telling you. First, we have a stationary. Stationary, it means it should be constant, the data, not a lot of variations, because a lot of variations, they will not give you an accurate forecasting. I will try to tell you again this one because this is important. We have model selection. When you put the data in the model selection, first of all, you have a stationary. Stationary, it means you should just make the data constant, not a lot of variations, because a lot of variations will make, let's say, so simply, a bad result. You cannot have an accurate result. A lot of variations, we will have a lot of variations also in the result, so you will not have a good forecasting. And then in the evaluation of these, for example, as I told you, the stationary time and then a seasonal time, at the end, if you see the diagnosis is okay by the AIC and PIC, then you can say we forecast correctly. I will show you how I did it. These are a lot of things. I don't want to just take your time. I know all of you are bored. So ACF and Dicky Fuller, first of all, we did the stationary. It's not stationary and it's seasonal. The seasonal, so simply I will tell you what's the meaning of the seasonal. The seasonal data is like, yeah, exactly. In the summer, we will have some data. In the winter, we will have another data. Let's consume the ice cream seller. The ice cream seller, when you have a shop of ice cream, in the summer, you will sell a lot. But in the winter, you will not sell a lot. So it's the same thing of the seasonal data. The seasonal data we will have in the car crashes. We will have the seasonal data in the car crashes. It means in the summer, we have a lot of accidents. In the winter, we don't have a lot of accidents. So the data is like a sine and cosine variation, up and down. So as I told you, if we want to make it a stationary, not a lot of variation, we should use some techniques like a differences. Difference, we can use the differences by the log and lag to make it a little bit more stationary. And I used second difference in my data to have more stationary data. Fine. And at the end, when you just make the data normal and stationary, and it's okay for finding or choosing a model by the R program, and I will show you even the codes, and also I can just send you the codes. We at the end we choose the ARIMA model, seasonal and non-seasonal, both together, 0, 1, 1. It's I should just explain a lot what's the meaning of these numbers, but so simply we choose the ARIMA model 0, 1, 1, and it's give us the best fit that we can use it for our predictions. So simply, we'll say the p-value, z-value, and standard deviation, coefficient of variation. So boxing method, as I told you, we standardized everything. And in the figure 4.6 in my paper, we would see the ACF autocorrelation function. And we see it's going to normal. There is no value who's upper than the limits. So it's tell us that the data and the prediction is fit. And this is our last forecast for the deaths of the people by car crashes in the next years. Yeah, we will see, fortunately, we have a decreasing model that will show us that the number of accidents and the number of the people who will die will going down. And for your information, I just try to accurate my model with the so fresh data that I found between my forecasting and the actual data. It's going to be same, and it will be as a suggestion for the next paper that we can use the forecasted data and the actual data to understand how much our forecasting model is accurate and fit. So this is the last prediction is going down. It's decreasing the deaths by the accidents, and in the conclusion we will have a good results, and we can tell to the companies, especially insurance companies, that the accidents here is going down. We will have some not say result, let's say causes. I cannot tell you the causes why it's going down because I just try to forecast it. But we know because of the quality of the cars, because of the let's say the roads is going to be better, and the government is working harder for giving the license to the people, so it will have a good result. In the suggestion, I suggest to the other researchers to try to find the causes, how these accidents happen, and try to reduce them. And also we can use, as I told you, the fit between the actual model and the forecasted model for the next, let's say, article or research. At the end, I'm really thank you because of, first of all, because of all the good articles that you showed to us. And thank you for the people that they hold this conference and cooperate with me, especially because I just signed in the last minutes. And if you have any questions, let's feel free and ask me. And I'll also use my email here. You can just email me for everything you want from the data or whatever from this article under another works. Dr. Kumar, I just finished my